Hey everyone, how's it going? So this video is a follow-up to the last one that you probably watched, where we're using this knowledge again. When you take the integral of a rate, that'll give you the total change. This one's going to be a little bit different. Here we don't have an expression for the rate. Instead, we have a table where the values of the rate are given. Okay, so you have two options here. One is use the table to make an estimation, or you can estimate an expression for the rate and then do like we did in the last video. Actually, for this one, I think that's actually kind of a good idea because this looks linear to me. Every time we're increasing by 0.5 in the x direction, and we are decreasing by 2 in the y direction. Okay, so in this case, I think it'd be super easy to come up with an expression for the rate and then take an integral, but let's not. I want to practice LRAM and RRAM again, maybe review that a little bit. Okay, so let's give this problem a read though. The rate in liters per minute at which water drains from a tank is recorded in half-minute intervals. All right, so this is the rate at which water drains out of a tank. Estimate the total amount of water drained during those first 3 minutes. Okay, so that means find the area underneath, right? Find the integral. All right, but in this case, we're going to use the table to estimate the area underneath. Okay, so we're going to do LRAM and RRAM. Okay, do LRAM first. Okay, so remember that's the left rectangle approximation method. Okay, so from 0 to 0.5 along the x-axis, that's 0.5 units. And since this is the left, we're going to choose the left rate. All right, now from 0.5 to 1, that's also 0.5 in the x direction. And we're going to choose the left rate, 48. From 1 to 1.5 is 0.5 units. And we're choosing the left, 46. And from 1.5 to 2 is 0.5. And we're choosing the left, 44. From 2 to 2.5 is 0.5 units, and we're choosing the left, 42. And from 2.5 to 3 is 0.5 units, and we're choosing the left rate, which is 40. All right, I'll figure that out in a second. All right, now I'm going to do the right rectangle approximation method. Okay, so let me erase this stuff. All right, so from 0 to 0.5 is 0.5 units, and now we're choosing the right rate, 48. From 0.5 to 1 is 0.5 units, and we're choosing the right rate, 46, plus 0.5 times 44, plus 0.5 times 42, plus 0.5 times 40, plus 0.5 times 38. Okay, one thing I know a lot of you have probably gotten in the habit of just writing the 0.5 out front and then not writing it for every one of these. Instead, you have all these numbers in parentheses, and that's okay as long as the 0.5 is always 0.5. All right, I took the time in this particular case to write it out in every single step because I want you to be aware that these may not always be nice even increments like this. Okay, sometimes you might get a table that starts at 0 and then goes to 0.3 and then to 0.4, then to 0.9, then 1.1, and then 1.5, and then 1.9. Okay, it's possible that might happen, and if that does happen, you know, this increment's 0.3, this is 0.1, this is 0.5, this is 0.2, this is 0.4, this is 0.4. If that happens, we need to make sure that all these numbers change too. Okay, let me go off the air for a second and figure out what these approximations actually are. Okay, so I filled in the left rectangular approximation method, 135, and the right rectangular approximation method, which is 129. Okay, and I'll show you why visually in a second, but if we wanted to do trapezoids to approximate, we would average these two numbers. Okay, so what's halfway in between these two numbers? It is 132. All right, what would the units be here? I think the units here would be liters, right? Because we're multiplying minutes by liters per minute, minutes by liters per minute, minutes by liters per minute. Okay, so that'll give us liters, which is good because they're asking us for the total amount of water drained, so we should be in liters. That sounds good because that's volume. All right, now visually what's going on, this is the graph. So this data table, I plotted up all those points into this graph. All right, so this is what we're looking at. When we did the notice here, it's a straight line, right? Like I told you it was probably going to be. It's a straight line. When we did the left rectangle approximation method, what we did is we drew this rectangle. We found the area of this, and then this one, and then this one, and so on. Okay, do you see how these rectangles all extend above? I'll try to draw better this time. All extend above that line. So that means this left rectangle approximation method is going to be an overestimate because the rectangles include these areas which are really not underneath the curve. Okay, and so that's going to be an over-approximation. I'm going to switch colors here for a second. How about this maroon? All right, so then when we did the right approximation, we went with these rectangles, right? Because we grabbed the right side and pulled it over. And so those are an underestimate because there is area above these rectangles that are still underneath the curve. Okay, and we could have known that because we knew we had a decreasing function, and since we had a decreasing function, we knew that the left sides were going to be above, where the right sides were going to be below. Okay, but let's also double check our work. Well, actually, let's see. So we said that our LRAM was going to be too big, and we said our RRAM was going to be too little. Let's go back and check. Sorry. Our LRAM was big and our RRAM was small, right? And our average was 132. And that should give us the trapezoid. The 132, I think because we have straight lines here, I think should be exact. Let's do a double check. Let's look at this thing geometrically. All right, the shape we have here is a trapezoid, right? We have an upper base and a lower base. And remember, the area of a trapezoid is 1/2 base 1 plus base 2 times the height. Okay, so base 1, how long is this line? It is 38 units. And then base 2 is 50, and its height is 3. All right, so let's see if we can figure this out here. Area is 1/2. 38 plus 50 is 88. Then times 3. All right, so 1/2 of 88 is 44. 44 times 3 is 132. So 132 is what we got geometrically. 132 is what we got using our approximation method, our trapezoid approximation method. Note, an approximation, a trapezoid approximation will almost never give you the exact answer. We're just in kind of good luck here because our graph was linear. Okay, so the area of this trapezoid was exactly that area. Okay, as always, if you have questions, let me know.